All right, guys, so today is a day where we're trying to put everything together that we have learned. In the warm-ups, you had this problem, and I asked you to use synthetic division to find these answers. And you all could do it just fine with the methods that we've learned. But what I want you to start doing is I want you to be able to do all of these at once and make a chart with them. Let me show you what I mean by this. I want to have the coefficients of my polynomial. So I'm going to have 1, -2, 1, -1, 4. Just watch. You don't need to do anything else. Here I'm going to make a chart, and I actually want to do the synthetic division for each of these numbers. -2, -1, 0, 1. When we're doing this, the first thing we do with synthetic division is we bring down this number and we get 1. Then we multiply. -2 times 1 is -2, and I add it to this. -2 times -4 is 8, and I add it to this. -2 times 9 is -18, and I add it. -2 times -19 is going to be 38, and I add it. This right here is my remainder. Okay? This is what I get. I get x cubed minus 4x squared plus 9x minus 19 with that remainder. This tells me the y value when x is -2. The reason we want to do this is we will be starting with 0. And then we're going to work our way down and we're going to work our way up. And we're going to be looking at these numbers that are called upper bounds and lower bounds. When I start at 0, I'm going to bring this down. I get 1. I multiply and I add. That's 0 add. That's 0 add. That's 0 added to that. And that's 0 added to that. As soon as I have my signs alternate, positive, negative, positive, negative, positive, that's going to be what I call a lower bound. So this could actually be called a lower bound. By knowing this is a lower bound, I know that this will not result in a 0. Watch what happens when I do this. I bring down the 1. I do -1 times 1 is -1, add it. I do 3 and I add it. -4 and I add it. +5 and I add it. See how that is not a 0? And I knew it wouldn't be because this is what we call a lower bound. This is the lowest 0 I could possibly have. Let's see. Maybe even 1 is our lower bound. We'll see. I'm going to bring this down 1. 1 times 1 is 1. Add it. That's -1. Add it. That's 0. Add it. And that's -1. Add it. And actually this one, this can be positive or negative. So see how my signs alternate. Positive, negative, positive, negative, positive. So actually this might even be the lower bound. Do you see what I'm talking about though? The very first time, the largest number I have where the signs alternate is going to be my lower bound. So right here, these signs alternate. This is going to be actually the lower bound. Maybe 2 is it. Let me see. Bring down the 1, that's 2 added, that's 0 added, that's 2 added, that's 2 added. Okay, so is that my lower bound? No.
I have a question.
Yeah.
So can't you like stop when you get to 1 and realize the signs didn't alternate, so you don't have to get to 2?
Exactly. Yeah, so like even when I saw this, I would have known then that I didn't even have to check these. Okay? I always start with 0. And if these alternate, I know that there cannot be any zeros down there, so it's not even worth checking. This actually, as soon as I see all the signs the same, this is what's called an upper bound. So now I don't even have to check 3 or 4 or anything else. This is my upper bound. There are no zeros beyond this. In fact, this is probably something that has what type of solutions? Imaginary. It probably has 4 imaginary solutions because the lower bound and upper bound are right there next to each other. Okay? Do you understand how I was doing that synthetic division and not showing every single step? That's the important thing there. All right, so we're going to do this first example off of the worksheet. So you're going to want to copy this down. Okay. So first of all, we're going to be reading the directions. Only use your graphing calculator for computations during the synthetic division. So if our numbers get huge and we need to grab the calculator, fine. Finding extrema, we have to use it for that. And checking your graph. We're going to round to 2 decimal places when finding extrema. All right, state the maximum number of roots. That's where we look at our degree. What's our degree? 4. That's our maximum number of roots. List all possible rational roots. That's where we do plus or minus. Can somebody tell me some of them? Keep going, Tim. Two-sixths would be 1/3. I think that's it, isn't it? Can anybody think of any others? All right, so that's it. Those are all of our possible rational roots. Now, we could have irrational roots, but these are the only ones that are possible rationals. In chart form, list the possible numbers of positive, negative, and imaginary zeros. Okay, positives. We look at our sign changes from our original function. Okay, how many? Jenna, what's it going to be? 2, good. So we could have 2 positives. Now we're going to check for negatives. So I plug in a negative. Negative to the 4th is positive, that's positive. Negative cubed is negative times negative is positive. That's going to be positive times a negative. That's a negative, and that would be positive. Trevor, how many possible negative zeros? 2. So if I have 2 and 2, of course, there's 0 imaginaries possible. What's another possibility, though? Amy, do you know another possibility we could have? There could be 2 imaginary. And then what do you want to do with these? 0 positives and then 2 negatives? That would be another option we could have. Michael, can you think of another one?
4 imaginary.
4 imaginary. And then what would these be?
0.
And I think there's one more possibility. You may know it? Tim? 2 positives, and then what else? Right. Okay. How did we get that?
Yeah.
That's because imaginaries have to come in pairs. So if I have 2 imaginaries, I'm allowed to have 2 positives, so that leaves 0 for that. When I have this situation, I have to make sure I get every possibility. So these all have to add up to be 4, and I have to think of all the ways they could add up to be 4. Okay. All right, state the upper bound and the lower bound. So for the upper bound, I'm going to have to see all of the same signs when I'm doing the synthetic division. For the lower bound, I'm going to have to see alternating signs. Okay, so we're going to come down here. We're going to make our chart. Our coefficients are 6, negative 11, negative 22, 1, and 6. I always like to start in the middle with the 0. I start by bringing down the 6. I multiply, I get 0, and I add. I multiply, I get 0, and I add. I multiply, I get 0, and I add. 0, and add. All right, so I'm going to check it. Signs alternating. No, that is not the lower bound. So I could have some zeros down here that are negative. So I'm going to check negative 1. Put in the 6. Negative 6, add it. 17 plus negative 22. 5 plus 1. Negative 6 plus 6. Great. Why do I say great? That's one of our zeros. Okay, I always like to put a little check there just so I don't forget that. So now I'm going to go down to negative 2. I bring down this, well, first I want to check for alternating signs. No. Okay, bring down the 6. Negative 12 added. 46 added. Negative 48 added. and then 94 added. Check. Positive, negative, positive, negative, positive. So what is that? That's my lower bound. So look back at my possible roots. -3, -6. Should I even bother checking -3 and -6? No. This is my lowest value that could have been a 0. So now I'm going to go up. 1. Bring down the 6. 6 added. -5 added. -27 added. -26 added. All right, so now I'm checking. I'm checking for all of these to be the same sign, and they are not. Okay, so we don't have anything working there. Let's go up to 2, bring down the 6, 12 added, 2, -40, -78. Okay, nothing working there. Go up to 3. 18 added, 21, -3, -6. Good. All right, so that makes me happy because there's another 0. We have to find 4 of them. On our way. Okay, we all want to check and see if it's an upper bound. It's not. I'm going to go a little further. Try 4. 24 added. That's going to be 52 added. It's 120 added. And that's 484 added. All right, so I'm going to stop now. Why? That's my upper bound. There cannot be zeros beyond there. All right, so now we can answer our questions. What's the lower bound? What's the upper bound? So our lower bound then is going to be x equals -2. Our upper bound is going to be x equals 4. All right, so now it says to find all the zeros. Well, we found a couple just by doing the synthetic division, -1 and 3. But we have to find a total of 4. Can anyone think of a way I could go about finding the other 2? Isaiah?
You could make an equation with the numbers that you got from the synthetic division from one of the zeros. So you could do like 6x cubed minus 17x squared minus 5x plus 6.
Okay, but I want to think ahead. Can I factor that equation that you just gave me by grouping? No, I can't. So what's another thing that I could do? Tim?
You know, you already have a positive and a negative 0. That means you're actually on a positive and negative, so you should check the other factors that they're not getting at the end.
I could do that. I could just keep checking these other ones that I have. Here's something that I'm not sure we've done, and this is the way that I think is the easiest. I'm going to take, say, this one right here. I have 6, 7, -1, and -2. What is the other one that I know already is a 0? What's the other x value that I know is a 0? -1. So I'm going to divide this by -1 because I know it's going to be a 0 for this. See what I'm doing? I'm basically, it's just like if I'm trying to do, say, 20 divided by, well, that's not a good example. Say 24 divided by 6. I already know that 24 can be divided by 3 and I get 8. And then I could divide 8 by 2 and get 4. It's a very weird way to divide, but do you see what I'm doing? I know one of the factors, so I can divide by that factor, and then I can find the missing factor. That's the same thing I'm doing here. I know one of the factors is -1, and I know one of them's 3. So I'm taking what I got when I divided by 3, and now I'm going to divide by -1. Okay, so watch what happens. Bring this down. That's 6. This is -6. That's 1. This is -1. That's -2. That's 2, and that's 2 there, and that's 0. See what I have left now? What kind of function is this one going to be? Quadratic. So I can solve quadratics very easily. We all can. This can be factored now. I'm going to try a 3x and a 2x. Then I know that the numbers have to multiply to be 2. Am I going to put a 2 here? Never will you have the same number in the same parentheses. 2, 1. This is a 3x, this is a 4x. I want to get a positive 1. What do? Look again, 3x, 4x. I want to get a positive 1x with the outers and inners. Negative on this one, and then positive on that one, right? See how that works? 4x minus 3x would give me the 1x. Can you solve this quickly then? We have 3x plus 2 is 0. 2x minus 1 is 0 now. What's this 0? What is it, guys? Negative 2/3. What's this 0? 1/2. Okay, so those are our other two zeros. So we could have done it that other way. I like what you were saying there, Tim, with just, checking those. My only fear is that because we had so many of them to check, it would have gotten a little tedious to do it. Okay? But you certainly can if you prefer. Write the polynomial equation as a product of linear factors when possible. Okay, so what was this as a factor? X plus 1. What was this as a factor? Good. Do you remember what this one was as a factor down here? And what was this one as a factor? Okay, so now these are linear factors because they're x to the first. That's how we know they're linear factors. You also could have written this as like x plus 2/3 and x minus, x plus 2/3 and x minus 1/2. You could have done that as well. But I think this is the better way of writing it. Because see how easy it would be now just to multiply it back out if you had to? Okay, find the x-intercepts and the y-intercepts. Well, we know that the intercepts are going to be negative 1, 0, 3, 0, negative 2/3, 0, and 1/2, 0. And what's the y-intercept? If you plug in 0 for x, what do you get for y? 0, 0, 0, 0. What is it? Okay, find the extrema. This is what we need to use our calculator for. Before we start graphing, we should find the extrema so that we know how to put our axes, how to label them. So we're going to do 6x raised to the 4th minus 11x cubed All right, guys, so once we have this put in, we're just going to do a zoom 6 and see how it looks. See if we like the way it looks. And I don't really like the way it looks. It's too squished together. Plus, I can't see that minimum down there. So to remedy that, I'm going to go in. I'm going to make my x's go from negative 4 to 4. And I'm going to make my y's go from, say, negative 60 to 60. I don't know if that's going to be good or not, but you know what? Actually, that's not going to be good enough. Because look at this. 2 goes down to negative 72. So I know this is going to have to be going down to at least like negative 80. Okay, so now when I hit graph, we're going to take a look. And that's better. All right, barely made it there. Okay, so I'm going to calculate this minimum right here. So I'm going to do second trace, calculate that minimum. I have to go to the left of it and hit enter, and then go to the right of it and hit enter. Enter one more time, And right there it is. So my first minimum is at negative 0.85, comma, negative 0.86. It's our first local min. Okay, next I have a max right there. So second trace, calculate the maximum. I have to be on the left side of it. That's good. Go to the right side of it. Enter one more time. Okay, and so this maximum is at 0.02, comma, 6.01. And then what else do I have? What's this one again? Another what? Minimum. So second trace, calculate minimum. Get over there close to the minimum. On the left side, right side. Okay, so here's our last one, another minimum. I'm just going to put it under here. 2.20, negative 74.85. All right, so now we're going to figure out our axes and what we want to do with these. Look at this minimum. It's going down to negative 75, basically. I might want to make these go by 20s. I think that'll be good. I'm going to go negative 20, negative 40, negative 60, negative 80. Okay, my x's, I want to spread this axis out because I got to fit in all these small points, like negative 2/3 and negative 1. That's going to be really hard to do. I'm going to make these go by 3s just for 1. So like, I'm going to call that negative 1/3, negative 2/3. I'm going to call that negative 1, negative 2, negative 3. You can, I mean, there's no right or wrong way on this, but I just think it makes it easier to graph it nicely. So negative 1, going to plot that point. 3, plot it. Negative 2/3 is there. 1/2 is here. 0.6 is right about in there. Hard to put that one. I'm going to go ahead and put in my maxes and min, my extrema. That one's very close. All right, so I have all this in there. So now I want to think about how this looks. I have another point here. Negative 2 is at 100. And yeah, that's pretty good there. Okay, so I know then that my graph has to come down like this, go through the x-axis, go to that minimum, come back up, go through the y-intercept, come to the maximum, go to that. What's 1? 1 is negative 20. Go through that point, come back up, and there we go. And that would be a good graph that I would expect to see. So I had to hit this minimum, this maximum, the y-intercept, and all those zeros that are in there. Answering these final questions. As x goes to negative infinity, as my x's go down this way, what's y going to? Neil, yeah. What's the question?
Like, where did the point, like in the top left corner? Like,
that point, negative 2, 100. Any other questions before we finish this? Okay, so as x goes to negative infinity, as x goes down here and gets closer and closer to negative 100, what's the y value going to go to? Infinity. How do I know that it never comes back down and crosses the x-axis? What did we just learn about? The lower bound, right? If this is the lower bound, it's not allowed to come back down and cross the x-axis because there can't be any more x-intercepts, right? There can't be any more zeros. So that would be the reason why. That's the lower bound. It's going to keep going up. Plus, if it's to the 4th power, don't we know that it has to go up, up, or down, down? at the ends. Okay, it should all make sense. As x goes to positive infinity, what's y going to? You guys, infinity. Okay, so that's what you're going to be doing on this. You only have 3 problems like that to do on your own. You need to finish up this packet that's due on Monday. Okay, you also need to do in the Kings Island packet, you need to finish up the worksheet, just the problem part. So here's what I'm talking about. These first pages. The very last page, this is not due until next Friday, the 9th. This is your project where you have to come up with a single polynomial function that could meet all of these requirements. Okay? And you can present that however you want. You can do it just on a Word document, you can do a PowerPoint, Prezi, whatever you want to do. All right? So you will have all of the rest of this period as well as Friday to get these 2 things done. And you can work with whomever you'd like to work with.